In this lesson, we're going to take a look at how much heat it takes to actually make a gallon of maple syrup. So here in Vermont, of course, maple syrup is a big deal. And so famously, it takes 40 gallons of sap to make 1 gallon of syrup. So what this problem is going to involve is that we're going to heat 40 gallons from 20 degrees C to 100 degrees C, because we can't vaporize until all the water becomes 100 degrees. And then we're going to vaporize 39 gallons. Okay, great. So let's do some conversions really quick. And I'll just show you one of my favorite little websites. Am I spelling gallons right? I'll find out in a second. It couldn't be 2 O's, right? Because that would be gallons. I don't think that's right. Let me share my screen really quick. And we will take a look at a handy little website that is called unitconverters.net. Okay, so you can see I've already been busy here. I want to go to volume, and we want to convert 40 US gallons, I spelled it right, yay, to liters, right? And so 151.4. Whoops. 0.4 liters, and a liter is 1 kilogram. And then we'll take a look at what 1 gallon is. And so that's 3.8. And therefore we can do math to figure out what 39 is. Okay, so I'm going to stop sharing. And we'll come back to this because we'll take a look at it, the heat as well. So I'm going to subtract this and figure out what 39 gallons is going to look like. So 151.4 minus 3.8. Okay, great. So 147.6 kilograms. Excuse me. So let's do heat first. And Q is equal to MC delta T. So the delta T is going to be 80 degrees. Right, so I'm going to be heating up 151 kilograms. Oops, 0.4. And 4,186 joules per kilogram. Right, remember heat, water's got a very high heat capacity, and then times 80. I don't know why I started writing units for that, but I'll stop because it does take up too much space. So let's finish this off for Q. So I've got 151.4 times 4186 times 80. And as you can imagine, this is a very big number. I'm going to shift to scientific notation and take a look at this. So this is 5.07 times 10 to the, and we'll check out units. So that's 3 and 6 and 7, 10 to the 7th joules. That's a lot. Okay, now we'll do vaporizing. And then we have a different form for Q. So Q is equal to MLV. Right. Okay, so now I'm going to look this up on the chart that we had in our previous video. So I'll share my screen so we can go and find that really quick. And let's see. I'm going to have to dig that out again. Well, you might as well just wait for me to get the number. Okay, and I was making a point about this in the video. So for water, it's 2260. So we'll write down the mass again. Now we're just going to vaporize 39 gallons. So that's 147.6 kilograms. I'm going to keep the units in this time. And then the heat of vaporization. So when I look it up on that chart that we had before, it's 2260, but I tried to make a big deal about it because for some reason the textbook shifts gears and now reports this out as kilojoules per kilogram. So we have a unit mismatch. If I had tried to do this all in one step, it would have given me a problem. Okay, so yes, of course, a big number, 333,576. Well, if you've ever been to Sugaring Shack, you'll know that they go through a lot of wood. But again, notice the mismatch here because this was reported in joules per kilogram and this is kilojoules per kilogram. So we want to watch out for that. But if I knock off 3 decimal points, I can write this now as 5.07 times 10 to the 4th kilojoules. And so Q total is going to be found by adding these two numbers together. Now I still have this on the stack here, and so I'm going to add in 5.07. And here's how you do scientific notation on a graphing calculator: second E and 10 to the 4th power. Right, so we added that in. And now I've got 384,276 kilojoules. Okay, now let's extend this problem. And let's suppose we wanted to do this, over the course of the day. My neighbors about a month ago had a portable little boiling pan, and they just had it on their driveway, and they were making some maple syrup. So let's suppose we wanted to do this in 8 hours. Okay, how much power would we need for that? And we know that power equals the rate at which we use energy. 8 hours, I can just convert this really quickly. 8 times 3,600, or could I use my unit converter too? All right, so that's 28,800 seconds. So so 384,276 kilojoules divided by 28,800 seconds. Okay. All right, so 384,276 divided by 28800. Yeah, that looks about right. And so that means I'm going to need 13.3, and this is unit of power, kilowatts. That's a lot. So in fact, let me take a look at some other units for this. So I'm going to, again, share my screen, and we'll go off and take a look at the unit converter. And we're going to look at, we ought to have something for heat would probably work, energy or engineering would probably work. Let's try this. Let's go to engineering instead. So let's go to power. There we are. Okay, so I want to go from, I've got 13.3 kilowatts. Lots to choose from here. And I want to see, what is that in horsepower? Yeah, it's 17.8 horsepower. And then let's see what else we have. Do we have anything in British thermal units? BTUs per hour. Okay. So I'll write that down. 45,381 BTUs per hour. Okay, I'll stop the share and we can come back and take a look at what we've got. Yeah, so finally we're taking a look. If I wanted to do this, so like our family gets out there and we want to just make 1 gallon of maple syrup, it's going to cost us a lot. In fact, I am not going to be able to find a hot plate that can output 13.3 kilowatts. I'm not going to find an 18 horsepower hot plate. And so, this brings us back to the idea about energy. It's not really just about energy, but how energy is delivered. And so by burning wood, you can get a lot more energy per second than you can typically with electrical appliances you plug into the wall. And so that really is a challenge, as we try and shift from fossil fuels. We have to remember that fossil fuels pack a really big punch, and we have to start rethinking or re-engineering how we use energy. So anyway, there you go. That's how we make a gallon of maple syrup.